Assalamu alaikum guys, welcome to chapter 8. I'm doing a supplement. The supplement for today, basically it covers a good 4 or 5 lessons. I'm picking a little bit out of everything, inshallah, to help you have more understandings of the properties of quadratic functions, what you're supposed to understand, what you're supposed to grasp. Anyway, so one of the things about quadratic functions is that it may have no zeros, 1 0 or 2 zeros. So what does that all mean? So if we go back to chapter 4, when we discuss what are the zeros of a function, and we're talking about a linear function, remember we have a y-intercept where it crosses the y-axis, and then we had zeros of a function. Zeros of a function, if you remember quite well back in chapter 4, it was your x-intercept. So in this case, let's take for example the first type of graph. Your parabola may go up or it may open down, right? But if it never ever crosses the x-axis, that is understood to be no zeros. Now, what does no zeros mean? Basically that the quadratic function itself, since it never touches the x-axis at any given point in time, it has no solutions. So in other words, those are the quadratics that you cannot basically factor at all, okay? So in this case, no zeros means no solutions. Now, what about the one that touches at only one given point? It's still a quadratic function, and usually these are the perfect square binomials that we've discussed, and they will only have one solution. For example, if you factored something and you got x minus 4 times x minus 4, which ends up being x minus 4 squared, there's really only one solution. So when it has only 1 0 because it touched the x-axis at one point, then it's understood that it has one solution. So one solution for this. Now, quadratics that pass through the x-axis at 2 given points, it has 2 zeros, and usually these are the quadratics that you factored, and you found 2 different binomials as factors when you've been factoring in the previous chapter. And it will have 2 zeros, okay? So this means that it has 2 solutions. So, and understand also that parabolas don't always open up, but in this example, so I just open them up, except for this one. Now, another terminology that you will hear is zeros of the function, okay? Another term that you will hear, and it means zeros of the function, solutions. So keep in mind that zeros of the function means solutions. It means x-intercepts. And then another word, if they tell you what are the roots, the roots are also understood to be the zeros of the function. So this is one way, if you had your EOC test, they could ask you what are the zeros of the quadratic function, what are the solutions of the quadratic function, what are the x-intercepts of the quadratic function, or what are the roots of the quadratic function. All of those basically mean the same thing, the x-intercepts or the solutions. So now let's come back a little bit. I've graphed a quadratic right here. I'm not perfect, but you understand that it's a quadratic. So just by observation, okay, there's different things that we can go ahead and answer based on our quadratic function. So the things that I want you to answer, this is called properties of quadratics and their solutions, okay? So first thing, I have axis of symmetry. So on a visual, it's very easy to see what the axis of symmetry is. Axis of symmetry is the line right down the middle, and it's the one right here where the vertex is at, that line itself. Where is our axis of symmetry? It's going to be this line right here. And what is the value of that line? Our axis of symmetry is basically that -1. So axis of symmetry in this graph is -1. Okay? Now through observation as well, what is the ordered pair of our vertex? We're able to figure out what is the vertex of the parabola. Well, in this case, it's the minimum, right? Because it's the lowest point. And all you have to do is start from the point of origin, which is right here, the 0. You go back 1, which is -1, -3. So the ordered pair there is -1, -3. So our vertex is -1, -3. Okay. Another observation that we know, it crossed the x-axis at 2 given points. So if I ask you, how many solutions does that parabola have? Number of solutions? It has 2 solutions. Okay? The next question is, what are the actual solutions? The actual solutions are those numerical values that you see. So one of the solutions is -3, the other solution is 1. So my solutions are -3 and -1. Now that's not the only way you're going to see a solution. Sometimes they'll tell you what are the solutions in ordered pair form. So obviously this ordered pair right here is -3, and remember that it's the 0 of the function, so your y is always equal to 0, so it's -3, 0, and the other solution is 1, 0. So as ordered pairs, we will see it as -3, 0, and remember, don't forget to put your parentheses, and the other ordered pair, sorry, this is not -1, this is +1, 1, 0. So these are the 2 ordered pairs that are the solutions. Now the domain. The domain, remember that it's always your input, your x value. So your input is unlimited. You don't have a restricted domain. You can put in the value of -100, +1000. So in this case, all real numbers. The domain is all real numbers. All right? Now, what about our range? Our range is always what our y-axis, okay? What's the lowest point that we go on it? Which way is the parabola going up? Since this is a minimum, the minimum is right here at -3. The lowest point on the y-axis is -3. But notice that the arrows go indefinitely up. So what would our domain, our range be here? Any number greater than or equal to -3. So in this case, we would write it y is greater than or equal to -3. All of our our range will be the lowest point, which is -3, and then it could only go up. All right? So now, there are times, like in a real world issue, that maybe your domain and your range are limited. So let's go to how that looks. Let's say, for example, you have, and you'll see this quite a bit, whether it's an object that's falling from a building, or maybe it's a dolphin jumping out of the water. So let's say, for example, we're talking about a dolphin jumping out of the water. Okay, so this will be time 1, 2, 3, and let's say that this is seconds. It's time, and then let's say it's 10 feet, 20 feet, and this is of course feet, 30 feet, 40 feet, and let's say that the dolphin jumped out of the water and it landed back in the water after how many seconds? After 3 seconds, right? So we'll estimate here, the highest point is right here. So if you roughly have to say it's about the height of 35 feet, that's as far as it went. So if you are asked to read this, number one, I could ask you, how long did it take for the dolphin to jump out of the water and land back? You know that it jumped at 0, started at 0, landed after 3 seconds. If I ask you how high up, what's the maximum that the dolphin reached in height, you would say about 34, 35 feet, okay? Another thing I can ask you, what is the domain? So the domain is your x value. The lowest value is 0, the highest value is 3. So remember, we go back to chapter 4. So for domain, the lowest value right here is 0. So 0 is less than or equal to x, which is less than or equal to 3. That would cover our domain, okay? Now our range Remember, it starts at water level. Water level or sea level is understood to be 0, and it went as high up as about 34, 35 feet. Let's say it's 35 feet. So the lowest point was 0, which is less than or equal to y, which is less than or equal to 35. So that's another way that you get to read this type of graphs. Now, what about when you're not given a graph and you're just given a quadratic function and you are asked, find the x-intercepts, okay? Now this you have been kind of doing, now it's just gonna add one more step to it. So let's say, for example, you are asked the x-intercepts. And when it's asking for the x-intercepts, what is it asking for? It's asking for the solutions, it's asking for the roots, it's asking for the zeros of the function. So let's say, for example, they give you y is equal to x squared, and then minus 9x plus 8. So you're going to have to go back to the basics of graphing, okay? So remember, what times what gives us 8. At the same time, when we add them, it gives us negative 9. So what are the factors of 8 that gives us 9? Only 1 and 8, right? 1 and 8. And since it's a negative 9, then both of the numbers are negative. And just remember, negative 1 times negative 8 is positive 8. Negative 1 plus negative 8 is negative 9. And then, since we're finding the zeros of the function, or the x-intercepts, our y is going to become 0, okay? And then we go into x squared minus 1x minus 8x plus 8. And then we go into the grouping. What is the GCF on the first half? X. What's the GCF on the second half? This is a minus 8x, so the GCF is negative 8x, okay? So 0 is equal to x, and then x squared divided by x is x, negative 1x divided by x is negative 1. Since this is a negative 8, drop a minus 8, and then negative 8x divided by negative 8 leaves us with x, and then positive 8 divided by negative 8 leaves us with negative 1. Before we close off, our parentheses are the same, yes? So then we can come up with our two factors. I'm gonna erase the conditions, guys. So here we are in the problem. 0 is equal to x minus 8 is one of our factors. The other one is x minus 1. The minute you have two factors like that, especially if they're totally different, you know that it has two zeros. Okay, so what does the 0 mean? It means that either x minus 8 equals 0, or x minus 1 equals 0, or both equal 0. So what you're supposed to do here is separate this now. 8 minus x will equal 0. X minus 1 will also equal 0. And then do the opposite or inverse operation to isolate your x. So get rid of the 8 by adding 8. X is equal to 8. And then add 1 to both sides. X is equal to 1. So your solutions, or your x-intercepts, are x is equal to 8 or x is equal to 1. So whenever it's graphed, the parabola number 1, we know the graph opens up. The points that it's going to be passing by are 1 and 8 on the x-axis. Now, sometimes it'll tell you what are the x-intercepts. You can answer this way. But if it gives it to you, what are they in ordered pair form, remember that your y is equal to 0. So this ordered pair would be 8, 0. And this ordered pair would be 1, 0. Okay? So now the last part of the lesson, you've kind of done it with linear functions before. Now you're going to do a comparison and contrast between quadratic functions. Now you learned a little bit of the properties in the sense of what's narrower, what's wider, how does it open up, how does it open down. So here we go. Your instructions are compare and contrast. So for example, let's say that I give you y is equal to 5x squared plus 2, and then y is equal to 5x squared plus 4. So first thing, let's look at the leading coefficients. The leading coefficients in both are 5. So neither is wider nor narrower. So the next thing we need to look at is our y-intercept, okay? So our y-intercept many times especially if there's no middle term, okay? And usually when there's no middle term, it tells us how it's translated. Is it shifted 2 units up or is it shifted 2 units down? So the comparison and contrast in this would be, and it depends which one is labeled first, right? So let's assume we're talking about y is equal to 5x squared plus 2. Then we say, how does it compare to the other one? So I know that 2 is 2 units below 4. So I can say y is equal to 5x squared plus 2 is translated, and the word translated means slid, like it's a slide. Translated 2 units below. And we would write y is equal to 5x squared plus 4. Or if we're talking the other way around, where we label this or list this one first, y is equal to 5x squared plus 4 is translated 2 units above, because 4 is greater than 2, it's 2 units above, y is equal to 5x squared plus 2. So those are the only 2 options. Usually, especially the assignment they're going to do is all multiple choice, so you really need to read the statement first. Which one is being mentioned first? Which one is being mentioned second? So be careful. It's either one of these 2 statements that is correct. Now, let's go to the next example. What if I give you y is equal to x squared? That's one function. And y is equal to 1/2 x squared. So number 1, they have different leading coefficients, right? They have the same y-intercept of 0. So we're not going to compare the y-intercept, of course. We're going to compare the leading coefficient. So since the leading coefficient here is 1, right? 1 is greater than half. And remember when we said that the lower the value between 0 and 1, the wider it gets. So since the leading coefficient here is the invisible 1, I can say y is equal to x squared is narrower, because it's rising faster, than y is equal to 1/2 x squared. Or the other statement, if we state this one first, y is equal to 1/2 x squared is wider than y is equal to x squared. So it's just about a play of words, what equation is listed first and which one is listed second. Now let's go to this one. Here's another one. What about y is equal to x squared plus 5? Y is equal to x squared minus 5. Both of them are facing up because leading coefficient is positive. Both of them have a leading coefficient of 1, so not one is narrower or wider than the other. But we know there's a translation, right? How many units apart are these? One is at plus 5 and the other one is at minus 5. So there's a 10-unit difference, right? So let's say that I say y is equal to x squared plus 5. Then I need to say how many units above, because this one is going to be the one that's higher. So is translated 10 units above y is equal to x squared minus 5. The other statement can be the other way around. Y is equal to x squared minus 5 is translated 10 units below. Because remember, negative 5 is below the lowest of the 2. Y is equal to x squared plus 5. So those are the only 2 options you have. Okay? One more example and then we're done. So here we go for this one. Now, of course, you can also use your calculator if you plug in, both equations, and you could look at them visually on the graph as well. So you might want to be able to, put your equation in and then you can do the comparison that way as well, up to you. But you should be able to do it without a calculator as well. So y is equal to x squared, and the other equation is y is equal to negative x squared. Okay? So in this one, It's vice versa. The same thing, whether which one is labeled first or second. Number one, leading coefficients. One is positive one is negative one. So as far as whiteness is concerned, the fact that both of them are one is positive, one's negative, not one or the other is whiter. Y-intercept, both of them are 0. So we can't compare the y-intercept. Not one is translated above the other. But what I can say, remember what we said, the positive parabolas open up, right? So if I am to graph this, okay, so the positive one would look like that. The negative one would look, and of course it has to pass through it has to touch the x-axis, okay? So what do you see in this case? If both of them are graphed, one's going up, one's going down, so regardless of which is listed first, you use the same statement. You can say y is equal to negative x squared is a reflection because they're reflected across each other. So it's a reflection of y is equal to x squared. Now, how is it a reflection? Is it across the x-axis or the y-axis? Obviously, it reflected across the x-axis, so you need to add that over the x-axis. Now, the assignment that you'll get in this, guys, is multiple choice. It's a visual. A lot of it is really quick to do. These ones, you might have to think a little bit about it, you know. But other than that, this is kind of like 4 or 5 lessons, and I chose just a little bit out of everything because I want you to have these notes. So if you have any questions, don't hesitate to come to class. Inshallah, we'll see you tomorrow. Assalamu alaikum.